Hello again, my name is Ben Zimmer and I'd like to welcome you to the next installment on the LV Mastery Tip Jar. In this installment we're going to talk again about the FIRST Robotics Competition. In particular, we're going to dive into a little bit more detail about the basic framework which is provided with the FRC version of LabVIEW, and which a lot of teams are probably going to use as their default choice. In the previous videos, we've used this framework to talk about how to make some simple modifications. For example, in the last video at the very end, we added a servo to this framework to demonstrate how to add additional outputs or inputs, actuators and motors and so on. So in this example, we're going to talk a little bit more about that, investigate it in a little bit more detail, and dive into how to create an autonomous mode. Let's start again on the basic robot main VI. If we click on our project window, we can always access the basic robot main VI by double-clicking on it. Then we can show the block diagram to investigate the code. So as we saw before, this code is provided with the FRC version of LabVIEW, and the modifications we've made here are really just two additions, similar to what we did in the end of the last video. I've added a servo. I open that servo by creating a reference to it outside the loop here and by feeding in the necessary channel. And in this case I've also added a gyro. So I've opened up a gyro sensor and I've attached it to analog channel AI1. As discussed in the last video, you need to open a reference to these objects, whether it's a servo or a gyro or any other object. You need to do that outside the while loop on the left hand side here. And then you wire into the basic robot main. We've done that here with both the servo and the gyro. And if we follow these wires around, we've also made copies of the servo close and gyro close, and we've wired those reference wires into them. So when we take a look at the teleop execute case, we see that we've got the gyro get angle, and if we turn on our context help, we see that that returns either the angle or the angular rate from the gyro. And we've got the servo set angle, which is going to allow us to change the angle of a particular servo motor. So this functionality of this code is really quite simple and frankly entirely useless, but it's good for a demonstration of how we can connect a sensor up to an output. And at any rate, we wanted to talk more in this video about the autonomous mode than the teleop. If we take a look here, we've got this block called the basic get mode, and this is a VI which is provided in the WPI library, and it's something which we should not modify at all. Essentially what it does is it communicates with the driver station and it finds out what mode the robot's in, and it spits out a value which is then used by this case structure to decide how the basic robot main should function. So if we pull down the selector of this case structure, we see that we've got the teleop execute case, we've got teleop reset, and the code sitting here will be executed whenever the teleop mode is reset. And we've got other. So other here is a completely blank case. And as it says here, this will be called for all other modes, such as disabled or autonomous. Generally, you should not need to place any code here. So here we've got a blank case for autonomous mode, and the instructions tell us not to put any code here. So it leads to the natural question of, well, how do I write my autonomous code? Where does it go? Okay, and the answer to that is actually sitting here. This is a reference to a VI called Autonomous Independent. So what does that mean that it is a reference? It's not the VI itself. Remember what we learned about the data flow methodology within LabVIEW. If this was a VI sitting here, it has an output wire connecting to the input of this while loop. In other words, this while loop wouldn't run until this Autonomous Independent VI finished, and that obviously doesn't make any sense for our application. So it is a VI reference. In other words, it is a way to tell the framework of the code where our Autonomous Independent VI is. And what happens is, behind the scenes, the framework is taking care of launching and shutting down our autonomous code. That's why it's not sitting here. It's not sitting in the teleop. Actually, if you look very carefully down into it, and we won't go through that at this stage, I think it's beyond the scope of this video. If you look carefully down into the code inside this robot basic mode, you're going to find where it automatically launches and automatically shuts down that Autonomous Independent VI. It is enough for us to know at this stage that if we want an autonomous mode, we've got to put our code into this Autonomous Independent VI. We don't have to worry about when it gets launched and when it gets shut down. So how do we get at this VI? This isn't the VI, it's just a reference. Well, it turns out because it is a reference, if we double click on it, it will open the Autonomous Independent VI. Alternately, if we were to go to our project window, we would see sitting here in the root of our project is the Autonomous Independent VI. So that VI is automatically created for us when we create a project. So if we take a look at its block diagram, we'll see that some sample code has been provided for us. So if we just read the notes here, open or use shared I/O resources, run until the autonomous is over. No need to check for when to end. This function will be terminated when time is up. And it talks a little bit more about the Watchdog. Essentially what we have here, and if I hide the context help, is we have a VI which performs an arcade drive, a delay, an arcade drive, another delay, and then it repeats that 4 times inside a while loop. So if we activate this autonomous mode, our robot is going to move in one direction at half speed for 1 second, in the opposite direction at half speed for a quarter second, and then it's going to repeat that a total of 4 times. And at the end, it's going to set the speed to 0. So if you want to try this out, all you need to do is flick this Boolean constant to be true, and then when you run your robot next time and you flick it into autonomous mode, it's going to drive. So be very careful before you do that. Before you click run, make sure that the robot is up on blocks or it's not going to run into a wall or do anything crazy. Don't let your mechanical team find out that the programming team broke it running some sample code. That'd be really quite silly. So what I want to talk about now is how can we make modifications to this to suit our own purposes. Obviously, I think it's safe to say that this autonomous code is not going to work to allow us to win any points in competition. So we're going to need to change this code to do what we need it to. So what we're going to do in this example is we're going to take the servo motor, which we've activated in our basic robot main VI. We want to control it in autonomous mode. I think what we'll do is we'll turn it to one extreme, let it sit there for 5 seconds, and then turn to the other extreme and sit there for 5 seconds, and then just repeat that continuously. So let's take a second now and look at what we need to do to achieve that. Let's go back to our robot main VI. Well, we have a servo set angle VI, which makes it very easy, and if we activate our context help, we see all that we have to wire into that is a number which represents the angle in degrees. So we know how to do this. We can put in a servo command, which is going to send it to one extreme. Then we can use a delay block, and then we can put it to the other extreme. But before we can do that, what we have to notice is when we wire up the servo set angle, we need not only to set its angle, but we need to tell it which servo we care about. We need to do that by wiring up a servo ref. So here in our basic robot main VI, we opened up a servo. We opened up the one attached to PWM9. So what we need to do to be able to talk to that servo in autonomous mode is we need to be able to access that reference. And when I talk about that reference, I'm referring to this wire. So before we get to the answer on how to do that, let's just take a quick look a little further to the left, because we noticed that that autonomous mode was talking to our motor drives. Let's just return to that to take a look at it. We see here we are talking to the robot drive. And where is that wire actually coming from? Well, we have this guy here. This is actually a global variable. And what global variables do is they allow you to make data available anywhere in your LabVIEW program. And naturally, this is how we're going to make the servo reference available. So we see we have 2 global variables here, one for the Watchdog and one for the robot drive. And we can see in both of these cases, these global variables are acting as outputs. In other words, the data is coming out of those global variables and then being used by our autonomous VI. If we return to the basic robot main, we see here that the reference that we opened to our 2 motors is being fed into the main while loop and being used by our teleop mode, but it's also being fed into this copy of our global variable. And the same is true for the Watchdog. We open up a Watchdog reference here, and we put that reference into the global variable. So what we need to do in order to make our servo available in our autonomous mode is to create a global variable for it. And there's a couple different ways to access our global variable to add things to it. The simplest is just to double-click on this global variable. And you see what happens, if I hide the context help, is that this basic Robot Global.vi is opened. If we go to the window and try and show block diagram, we'll see there is no block diagram. A global variable is essentially a VI which allows you to store data, but it does not have any code whatsoever. It's merely a repository for data.